All right. So today we'll be looking at chapter 12 of Devops for data science, and it's on computer networks. So yeah, as I was saying just before we started, yeah, it looks like the last cohort didn't really focus on the theory. They were more interested in the labs. And for me, given that I don't know anything about this, I was more interested in the theory. So I ended up having to just create my own slides, which is what I did. But yeah, as I said, I did not do the labs. So if there is somebody that did the labs or at least in their day-to-day works with this stuff, it would be great maybe if we could hear from them. But yeah, so I'll just start. So the big picture, the idea really is to set up your stuff on the server and then make it accessible to users who need it. I suppose in some cases, you could just be the user that needs to access the server. And then in the book, the author uses this analogy of, so you can think of your server as an apartment building, and each service lives in one apartment waiting for mail. So the whole analogy is based on like the physical mail that we are used to. And then in terms of the model, he says network traffic exists on a call and response model. So basically you send a request and then you wait for response. Yeah, I think these are some of the things that I was kind of, at least it didn't sound new to me. And then in terms of protocol, there is TCP IP, TCP, that's transmission control protocol. And then IP is internet protocol. It is internet protocol, right? Where's the book? Yeah, internet protocol. And this basically defines how messages are addressed, packaged, and delivered. If we are going with the analogy, we were saying this is more like the language that that we agree to kind of communicate in. And then anatomy of a URL. Yeah, this is something that I've actually just always had a little bit of an idea about, but it was good to kind of get some more details around it. So essentially, you have the protocol, which is this part here, and this basically just defines the traffic type, or with using our analogy, the language, and then you get the domain name, which is what I think most people are familiar with, and that's just the human readable server address. In this case, we've got google.com, and then we've got the port, where on the server to direct traffic. And then lastly, we've got the path. So this is basically a specific resource on the server. With our analogy, it's more like the intended recipient in the apartment. Yeah, and then he also mentioned some default ports here. I think I do cover them again in the slides, but port 80, that's HTTP, and then 443, that's HTTPS. Yeah, I think a thing that was interesting to me was that every time you type a URL, normally we don't put this 443 or 80 just because like they're there by default. But yeah, that was quite interesting that there is that port there. Okay. And then IP addresses. So this is the actual address identifying the server location. So the domain, it seems, resolves to the actual IP address. And I think in the book, he does says, so that happens using the domain name service or system. So that's how you go from the domain name to the IP address. All right, and then he says if you've seen an IP address, it's likely been IPv4. I've never actually had anyone say this, so I don't know how it's pronounced. I don't know if you say IPv4, IP version 4, but I think it stands for Internet Protocol version 4. And so these are 4 8-bit blocks with like so it's those 4 numbers separated by dots. In this case, we've got 64.56.223.5. Sorry about that. And then there's about 4 million or so that are possible. and we are running out apparently. However, there is this new version, which is the IPv6 Internet Protocol version 6, and these are 8 hex blocks, and they're separated by the colons. They are much longer, but then he shows that they can also be written. There's like a short way of writing them, and these are practically unlimited. That's just because the possibilities are just significantly larger compared to IPv4. Yeah, there's gradual adoption underway. So currently, there's both IPv4 and IPv6 are being used, but he says like the idea is that we will eventually move on to the IPv6. If someone knows how these are supposed to be pronounced, feel free to just let me know, because I don't know why it just feels weird to just be saying IPv6. Yeah, and then he talks about special addresses. I think the one that I'm super familiar with is the local host. So that's 127.0.0.1, or rather dot. Sometimes it just writes localhost, and this is basically where the machine sends the traffic back to itself. He actually says this happens a lot more than we may think. And then he also talks about private IPs. So apparently private IPs start with 192.168 or 172.16 or 10. So these are used exclusively in private networks. You wouldn't find them in public. Yeah. And yeah, that's pretty much around IP addresses. And then the next section is on services and ports. So essentially each service runs on a unique port. And there are over 65,000 ports on every computer. I think this is something that I kind of had a sense of, because I know if, oh, I think there's a chat. I really want to get a doormat like this. Oh, I think that's that. Oh, I just clicked on the link that you sent. There's no place like home. Oh yeah, I actually love it. I love it. Um, yeah, so I think with the pods, I discovered that if I'm doing a Shiny app, so normally I like to say in my that run app function which port to use. And if like I try to run it while, for example, that port is being used, the machine will tell me that the port is being used. So I kind of had a sense that each service runs on a unique port. As I said, there are over 65,000 ports on every computer. And then some common default ports. I think as we already saw, HTTP is on lessons on port 80, HTTPS 443, and then SSH 22, RStudio Server 8787, and Jupyter Hub 8000. So he does point out that authors of like server-based software determine the default ports, and generally they tend to pick higher numbers so that they don't basically interfere with the other ones. Yeah, and then there was also this, I don't know why I made it a warning, should have just said note. Yeah, so multiple services can share the same port. So if you do want to have, say, a bunch of services on the same server, then you have to use what is called a proxy. And examples are Nginx and Apache. So this allows you to then route to different paths on the same kind of server. I think we'll get more into that. This is like foreign ground to me, so feel free to just correct me if I start saying things I shouldn't be saying. But I tried to get stuff from the book and try to understand them as they are in the book. All right, so using a proxy, this is how I understood it. There is another image used in the book. But yeah, I just thought this was much nicer, or rather, I just wanted an excuse to use this diagram thing. So basically, there's a user request, and then let's just assume this is now someone trying to access RStudio. So for example, if the domain is example.com, so it could be something like http example.com/rstudio. So now this will come on Nginx through say port 80, and then Nginx will check that okay, this person wants RStudio, and then it will come to this port. So the idea here is that all these services are on the same server, and the user cannot really access them directly. They have to go through an Nginx. I think he does point out that if you happen to have just one service, then you might as well just use like one of these ports. Basically take it to where the traffic is coming anyway. At least that's how I understood it. But if you do want to have multiple services on the same server, then you can use like a proxy like Nginx as shown in this diagram. Just so that I show you. If I put, are you guys able to now see what I'm sharing? I'm sharing the book. Can you guys see that?
Just the slides.
Oh, because I am sharing that Brave. Okay, I think I'm sharing the I'm sharing the not my entire screen, but just a tab. But the diagram in the book is not too different from this, but it's not exactly this. Um, all right, so as I said, these proxy options, they're free slash open source options. Nginx is one of them. I suppose Nginx is one of the most popular because I always hear people talk about it a lot. Yeah, Apache I've also heard quite a lot. Hopefully I'm pronouncing that correctly. And then there's some paid services, Citrix, Fortinet, and Cloudflare, and then F5. I think you also noted that the F5 team is the one that's kind of maintaining Nginx. Yeah, I'm not really too familiar with this stuff, but I just put it there. And then firewalls and security groups. So basically, block traffic to all ports except those explicitly allowed. Um, Here, he mainly focuses on AWS. So he says the default firewall mechanism in AWS, this thing is called security groups. Yeah, which I think I know when, if you're like creating a new instance on AWS, during that process, you do have to either select or create a new security group. And then, yeah, he says once you've created an EC2 instance, only port 22 is open, just for SSH. You have to manually go and open ports 80 and 443 for web traffic. Yeah, and then he says if you happen to be having issues, so if you're basically one way to check if there's a chat thing there. I don't think it's on the book, but if I remember correctly, ports below 1024 restricted for regular apps, they need system level privileges. Oh, I actually didn't know that. And yeah, I don't think I saw that in the book, Diana. But yeah, I didn't know this. All right, yeah. So if your system service hangs and times out, go check the security group first. And then, oh yeah, another thing he points out is that so besides firewalls just restricting what traffic, where basically where you want to allow traffic, you can also choose which IP addresses can access the server. And I think I've done something like this because I think there was one time I had set up a WordPress website and I wanted to access the database. And to do that, I have to go to the MySQL database and basically tell it, put my IP address in there such that I can access it. And I remember it was a bit of a pain because the IP address kept changing. It was dynamic. And he says the IP-based restrictions are brittle, use sparingly. Yeah, and then some debugging tools. So if you're having issues, one of the things that you can check is use your browser dev tools. I would imagine most of us are familiar with this. So you inspect network traffic, status codes, and timing. I've never actually have to debug any networking tools, and I think that's just because in my work I mainly program really, and I don't deal with network stuff. But occasionally, if I'm doing like a Shiny app, I do find myself looking at the dev tools. And then there is this idea of SSH tunneling. So what this allows you to do is to access remote ports locally. Um, yeah, so he has this the kind of syntax. And then the example is if, for example, on your server you have, I think this 8000 is for Jupyter Hub. This is what it would look like. Yeah, I think if someone knows more about this, and I'm happy for them to just chat to us more about it at the end. And then how to check open ports. So this is the command that's in the book. I was not actually able to run it on my machine, but because I'm running a Windows thing, so I just assumed this is more of a Linux one. But then on Windows, this seemed to work for me. Um, and then you can also check if a host is reachable. And then I think on Linux, then this is the IP address of the book. So you can just do ping -o and then the IP address. On Windows, you kind of have to say ping.n. The one just says try it once, because I think there's an option to just keep trying it until the user closes it. It's like Control C or something like that. For some reason, when I was putting together the slides, I could ping this and I would get it, but then just before the meeting, it was no longer working. And yeah, I'm not sure what's going on there. And then to check HTTP status, in the book it says cal dash capital letter I. I think this is on Linux as well because on Windows, if I just do cal, I get like a whole interactive thing, which was a bit strange. But then if I do cal.exe, well, I had to Google to find out that I have to do this. Then it works out nicely. You do get that the thing is reachable if it is. So I think it just returns HTTP, the 200 status code, and a bunch of other information. Yeah, and like I said, I did not do the labs, so this is gonna be pretty much super short. But I am open to someone else sharing more if they did do the labs or if they work with this more frequently. Yeah, my next slide really is just the key takeaways summaries. So URLs have four parts: protocol, domain, port, and path. IP addresses are the actual locations. And then the domain name systems maps domains to IP addresses. And then each service needs its own port. And then if you want to have like all the services in the same server, you can use a proxy to route traffic to the right place. And lastly, firewall/security groups control which ports accept traffic. And yeah, that's pretty much it. For someone like me who doesn't really work with these things a lot, this was quite helpful. Yeah, I tried to do a little bit of I tried to do the labs, but on this Windows machine, it was a pain. So then I just left it. But yeah, if anyone has something they want to share, I'm happy for them to do so. This is the end of my slides. And if no one has anything, then I suppose I'm happy for us to call it a day. I don't think it would be a good idea to ask me questions because I probably wouldn't know the answer anyway. How do I bring back the Zoom? Maybe just stop sharing. Then it'll come back. Yes, that's it, everyone. I don't know if anyone has some stuff they want to add. Maybe if you looked at the labs.
Just a question in case I like you, Rhett, I didn't know anything about networking before this chapter. It sounds like you knew far more than I did before this chapter, but I've always been curious, and maybe this is like just a small technical point, is like port 80 and port 443, are those just conventions that most tools follow, or is there something special about those ports? That 80 is for, let's say like
HTTP.
HTTP traffic and 443 is for HTTPS traffic. Just curious if anyone knows.
Yeah, from my understanding, I got the impression that it's the convention. I'm actually not sure. Maybe Diana, you have some insight on that?
I think
Or
you're right. They're just conventions. Yeah, like they decided to use those ports, but in my understanding, I don't know that much about networks. It was a subject that I never actually liked uh, when I was in college. But I mean, they're interesting, right? They're very interesting. But yeah, on my understanding is that all ports work the same way. Although now I'm not sure because the UDP, UTP thing, I'm not sure if some ports are only used for UDP or if that comes like in a different layer. Uh, but yeah, I think the port numbers are just conventions, and yeah, you're supposed to use like higher numbers for your applications because of the 1024 thing. The ports below that are restricted.
Hmm. Yeah, I think another thing that I looked into, I was reluctant to talk about this because I wasn't too sure about it, but it seems like, for example, because the 80 and is it 443, given that they're the convention, apparently if then the alternative would be like the user having to actually include the port in there. So rather than example.com slash say App Studio, you'd have to have like a port in there. But now I think the browser already knows for HTTPS it's 443, for HTTP it's 80, so you don't have to include it. I'm not sure, which is why I didn't want to get into it too much. Yeah.
And
Hopefully I
actually,
answered your question.
sorry, for the labs, and also the diagram in the book, I was left a little unsure about these port numbers for Jupyter Hub and RStudio Server. Are these the default ports that those apps expect, or is that some setup that you need to do? And even if they're the default ones, could you change it somehow so that you just do like a proxy that would forward it? Okay, I see Diana nodding, so I guess the answer to both is yes. Okay.
Yes, yes, they're just the defaults, and you can change them so that yeah, if you're setting up RStudio in a server, you can change the port number, and everyone can just like connect to that other port number that you set. And I had a question about the ping, because the book says that it said this book lives at 185, 199, 110, 153. But I don't think that's right anymore, because if you put that address in the browser, like it should go directly to the book, but it doesn't work.
Yeah, I was also trying it and I saw that it didn't work, which is why when I was presenting, I didn't even like to bring out the terminal and start pinging.
But the ping still goes through. So I guess
Yeah.
one thing is the ping, like the direction exists, but then it returns 404. And that's like a different thing. So the IP address is there, and it's returning packages, but the web page is no longer there anymore.
Ah, I see. I wonder if maybe he moved it and did not
Maybe.
update.
Maybe.
Yeah. Um, but yeah, for me, this was quite helpful just because this is something I know little about, and I think he wrote it in such a way that it wasn't too complicated, at least for me. Yeah, but that's where I'm at.
I have a question for the group. How would you understand security groups? I've kind of set things up on AWS before. It was really just a, click this, click that kind of thing. But I was wondering, like, how do you actually understand security groups? Like, my mental model was a little bit that it's maybe this is not the right thing, but it's sort of like I have an EC2 instance, and then I have a relational database, and then it's how these two things within like AWS own like infrastructure communicate with one another. So it almost felt like it was, I don't know, at the risk of abusing like terminologies, if I were setting up like a Podman pod or Kubernetes thing, it's like it's like within its own network, if you will. But could that be extended to things that are in different places? I don't know. I'm rambling too much. How did you guys understand security groups? Just curious.
I'll start by pointing out that I didn't understand them. Because I also wasn't sure how I could understand the idea of the proxy. But then when he said on AWS security, I wasn't really too sure how then how the two are related. Like I don't know, Diana, if you have like a better insight.
No, not at all. Not about security groups, but I don't think it's uh no, I have no idea. So I only remember that like once to enter like to SSH to a server, we had to like go through a different port and just like do a little tunneling, but I'm not sure if that's related to that. Maybe it will be a good thing to look at and then discuss on Slack.
Yeah, because I know
Or
when you set up that EC2 instance, after
wait,
you've done the thing. Oh,
wait. I just remember. So you set up the instance, and then in the network you tell the network which IP addresses are allowed to ping to that, well, to ping and to SSH and to enter that IP address. Yeah, those are the security groups, right? That's why if you set up a virtual machine like in AWS or Google or wherever, you have to I have to like keep changing the IP depending on my public IP of where I am, so that I can actually enter the virtual machine. I think that I think that it's that, right, Arthur?
I'm not sure. I mean, I think I was just thinking like, let's say you have a cluster of stuff that's linked together, right? Or no,
Mm-hmm.
actually, I like your description better. I guess it's a set of things, like a set of IP addresses that are allowed to talk to one another without coming through like the firewall first, right? Or like coming through a proxy first. And maybe in the case of AWS, if you have like a few different instances that work together, like a compute instance and a database, for example, like they'll have, I guess, a fixed IP address. They'll have an IP address, and then you're saying like these two things can talk with one another, I guess. I don't know. I'm starting to move towards that understanding. Maybe that understanding is completely wrong, but that's what I think I understand.
No, I think you're right. I think you're right.
hmm. I don't know if there are any other questions, or should I just type stop, end? I'm not sure what it. I think it's stop.
Oh, sorry, and I just share an image, and like you can also ping the address, and it actually says that oh no, yeah, it changed from 110 to 108. So if we
Oh,
yes, that was it. 105 to 199.
Also, you
the
pinged the domain directly. You just
you can
say,
also
oh, I
ping
see.
the domain and you get the address 153. I mean, if you put that in the browser, it still says that it still returns 404, but I guess if you do that in the browser, you have to do like something else. Or I'm not sure, but yeah, like the address change.
See, see.
I wonder if like and I guess this maybe leads into the next chapter or subsequent chapter is if there's some sort of like at the IP address that we're pinging, if there's a redirect, like so if in essence, like are we contacting like the DNS server that knows like the authors, I guess they've procured a domain name for publishing the book, right? So I wonder if like we're what that address is that Diana showed, if it's the address of a DNS server that then routes like redirects us towards the actual IP address, or yeah, or what it is.
Yeah, I also
Yeah, I
want.
know. Yeah, I know. I don't know. But yeah, it could be that because yeah, it could be that.
This networking stuff, and frankly, just all the cloud thing just seems like a recursive rabbit hole. You know what I mean? It's like
Yes.
you go to one
Yeah,
topic and it's
yeah,
like, what is this topic? And then you learn it's like, okay, you need to learn about another topic and keep on going like ad infinitum,
Yeah.
yeah.
literally, that's how it feels.
Yeah.
It is, yeah. I am struggling with setting up a Shiny proxy instance on Google Cloud, and I'm going through all of these steps, and a lot of it's something I don't understand.
Yeah. I suppose at companies, there's probably like people who are just dedicated to this kind of stuff. So then makes life much easier.
Yeah.
Yes. Yeah. And also like it's so weird 'cause this is so fundamental for how the internet works and we don't know that much about it. And then like things, I don't know if you were affected by the Cloudflare down thing like this past week, like something like that happened and it's like wow, like really like the internet is just like it works almost by miracle.
Yeah, I just saw that the AI assistants were not reachable. It's like, oh, okay. Hectic.
Okay.
Uh, Thank you so much, though, guys. I think if there aren't any more stuff, I'm happy to press stop. Is it stop or end, actually? I think it's stop, right?
Yeah, stop.
So stop.